Precalculus 2.5 Day 2 notes. So we're going to be writing polynomial functions and applying the complex zeros occurring in conjugate pairs as we do this. And so this theorem here is let f be a polynomial function that has real coefficients. If a plus bi, where b is not 0, just meaning that it's got to be a complex number with an imaginary piece, is a 0, the function, then the conjugate a minus bi is also a 0. And so in this first one, find a third degree polynomial function with integer coefficients that has 2, 7i, and minus 7i. These are those complex conjugates. They already gave you that both of those are zeros, or roots. And if those are zeros or roots, meaning x equaling 2 is a 0, x equaling 7i is, and x equals minus 7i are roots, set them equal to 0. And it means that this polynomial, and it needs to be a function, so let's write it f of x, set x equals 2 to 0, and we get x minus 2. X minus 2 is a factor. Set x equals 7i to 0, you get x minus 7i. X minus 7i is a factor. Same thing, we get x plus 7i are factors. So you're going to need to multiply this out. You can't leave it just in factored form. And so it needs to be a polynomial function. You need that function notation as you work through. But we, in a lesson or two ago, we multiplied complex conjugates. And what we found, it's that a minus b times a plus b kind of scenario where when you multiply it, you just get a squared minus b squared because the middle two terms are always the same. So we want to go ahead and multiply the complex conjugates first. You're going to get x squared, and you're going to get a minus 7i times positive 7i, a minus 49i squared, which is going to make that x squared plus 49. So you want to multiply the complex conjugate factors first. So anyway, so then now keep on multiplying it out. Distribute your x. Distribute your minus 2. And your final answer, make sure you have function notation. Write it in descending powers. And there you have your polynomial of degree 3. Oops. Yeah, that's a little better. All right, example 2, find the cubic polynomial function f with real coefficients that has negative 3, and this is supposed to be 2 plus I as zeros, and f of 0 is equal to 30. So we're going to have to make sure that this point satisfies it at the end, so it might have a vertical stretch or shrink to it. But you have to know that if 2 plus I, it's cubic, right? Your roots are x is negative 3, x is 2 plus I, or x, you have to know that they come in complex conjugate pairs since it has real coefficients. And by the way, they said integer coefficients up here. Well, integers are real numbers, so they had to have the complex conjugates as zeros. But they were nice and gave it to you there. Here you have to just know if 2 plus I is, and there are real coefficients, you also need 2 minus I. So now there's kind of a trick to the factors in getting this to multiply out. And so f of x is, it's going to be x plus 3. Move the 2 and the I to the left. I have x minus 2 minus I, and then x minus 2 plus I, if I would put those all equal to 0. And the key is to group inside these parentheses, and I'm going to do it in a different color. Group the x minus 2 like this, and treat this as an a minus b times an a plus b, which gives you that a squared minus b squared. But your a term is the x minus 2, and your b term is the I. So just pausing and letting you kind of look at that a little bit because I'm going to erase that. But the key to make this go smooth in terms of multiplying it all out, that is the key, is that you need to group those like I just did and think of it as sum and difference being multiplied. So as I go to multiply these, I'm going to leave this x plus 3 for right now. Notice I wrote the f of x equals, I brought an equals down. And then here it's going to be that binomial squared minus the I squared, that a squared minus b squared. And then I'm going to expand inside. When you square a binomial, it is a trinomial. It's going to be x squared minus 4x plus 4. That's just that x minus 2 being squared. And then I squared is a negative 1, so we have the opposite of a negative 1, so we're going to have a plus 1. So it just takes practice, and once you get the hang of it, that can go a lot faster, but it just takes practice. And so now you need to multiply this out. X cubed minus 4x squared plus 5x plus 3x squared minus 12x plus 15. And just collecting like terms. The problem with this is this point has to satisfy this. And what we have to do is realize that this might contain a vertical stretch. So while this has a 1x cubed, maybe it's something other than a 1. So maybe this has some vertical stretch. And so I'm going to now plug in the point 0, 30 for y, and solve for a, and 0 for x. Well, that kind of works out nice because that ends up just being 15 times a. If I divide by 15, a is 2. So that means I need to plug that back in. So my f of x is actually 2 times the quantity. This is an important piece to remember. And so my final answer, so that it will go through the point 0, 30, is this. So when they give you a point it has to go through, you have to consider a vertical stretch and plug that in and find the value of a and redistribute that. All right, find all zeros given that 1 plus 4i is a 0. Well, that means that factors, excuse me, are going to be x minus 1 minus 4i. And if 1 plus 4i is a 0, 1 minus 4i is a 0. So x minus 1 plus 4i. And what you're going to do on this one to find the zeros, it's cubic, and I need to get it down to not be cubic. So I am going to have to realize that to get it to be cubic, it must be those, and I'm going to regroup those and end up multiplying those out. But that would only get me an x squared. There must be some other factor that I'm going to have to figure that multiply to be that x cubed minus 4x squared plus 21x minus 34. So multiply these first two out and use that x minus 1 squared minus 4i being squared, knowing that the middle two terms will cancel, and just know there's going to be another term there. Excuse me. And so here, square out the binomial. Square of a binomial is a trinomial, x squared minus 2x plus 1. And 4i squared is 16i squared, which would be a negative 16, and the opposite of a negative 16 is a positive 16. So I have x squared minus 2x plus 17, whoops, times something is going to equal this x cubed minus 4x squared plus 21x minus 34. So what I'm going to do to find this is I'm going to do longhand division. I'm going to divide x squared minus 2x plus 17 into this polynomial. And longhand division is what I'm going to need to do. So to get x squared to match x cubed, I'm going to need to multiply by x. So I'll put it right over the x term. And then I need to subtract or add the opposite. I'm not done because my remainder is of the same degree as my divisor. I need it to be of smaller degree. So I need the x squared to match the minus 2x squared, so multiply by minus 2. And then when I subtract, which I can add the opposite, you get 0. And the remainder better come out to be 0 because it has to be a perfect factor here. And so this quotient of x minus 2 is going to be your factor. So this is going to be x minus 2. That's what needs to fit there. So find all zeros means but remember that these came from zeros of 1 plus 4i and 1 minus 4i. So my zeros are 1 plus 4i, 1 minus 4i, and then 2. Those are going to be my zeros. All right, in example 4, write this as a product of linear factors and then find the zeros. So we need to factor this, and it's of degree 4. Well, first of all, I can pull out an x. So 0 is going to be a root or solution to this. And I'm left with x cubed plus x squared minus 14x minus 24. And that's not going to factor by grouping or anything, so that means I need to go back to my rational root theorem to try to whittle that cubic down to something that's quadratic that I can then either factor or use the quadratic formula on. And so my possible rational roots, I've got p over q plus or minus factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. That's how I kind of write them. And then factors of 1 are just 1. So my possible rational roots are plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Now, it might take you a while to get those, but now that we have them listed, I could go to Desmos. Let's see if I can do better this time. Okay, so go to Desmos and put y equals, and I studied out, so if I just go x to the 4th, x, and then if I hit the a squared and then back up, oops, and delete, I can make that to the 4th. And then arrow to the right so that I'm there, and then plus, and then x squared, I can back up, back arrow, delete, and I can make that an x cubed, arrow to the right, minus 14 x squared and minus 24x. So it's giving me which ones I should try. Matter of fact, it's giving me all of those. But you need to support it with synthetic division, so choose whichever one you want. Notice that my zeros are 4, 0, -2, -3, but without work and without synthetic division, you get 0 credit. The idea of looking at the graph is to narrow down that long list of rational roots so that we can start with, I'm going to start with 4. And this is the process. If you have only answers, you will not get credit. So I saw that 4 worked. So I'm going to go and use 4 synthetically. And I already know one factor is x, so I'm just going to use the x cubed coefficients. So 1, 1, minus 14, and minus 24. Bring down the 1, multiply, add, and there I have my remainder of 0, which is what I needed. And then this represents x squared plus 5x plus 6. So that means I can come here and write this as x minus 4, and then x squared plus 5x plus 6. So it said write h of x as a product of linear factors. So h of x is going to be x minus 4. 4 was the root, but the factor is x minus 4. And then the x squared plus 5x plus 6 is going to factor to x plus 2 and x plus 3. So there I wrote it as a product of linear factors. And then the roots or zeros are what makes this 0, which we can verify with the graph. So we have 0, 4, -2, and -3. And those are my zeros. So I wrote it as a product of linear factors, and I showed synthetic division and how I obtained that, and the list of possible rational roots. That is the work that you need to have on your paper for those.